It can be applied to all kinds of questions, P3 topics all the way to P6 topics. Okay, so I'm going to start revise the very basic terms, and then I'm going to show you exact examples from actual past PSLE question, and see how the techniques that I'm going to show you can be applied to the questions. Okay, so again, if you have any questions, you can write down on a piece of paper. Later on, at the end of the session, I'll give you lots of time to ask any questions related to what we're going to discuss. All right. Okay. Now, first, we are going to answer this question. What are experiment type question? Now, I would say that experiment type question in PSLE science is it is the biggest component type of question, or the biggest kind of the most important kind of question, because it carries up to 30% of the entire paper, and it appears in both the multiple choice question as well as the open-ended questions, and it can appear in any of topics, even life sciences as well as physical sciences. Okay, so that's why experiment type question is very important, and you need to know the answering techniques. Okay, how to approach, what are the things to look out for when you see experiment type questions. Okay, so experiment type question may require students to identify the aim of the experiment. Scientists, they always we want to discover things, right? We want to find out about things, and scientists discover things or make certain conclusion by carry out experiments. Okay, so in experiments, they have to formulate hypotheses. Okay, formulate experimental questions, devise a method, create several setups. Okay, to answer those questions. Okay, and then to verify the answer, whether the result of the experiment is reliable or not. Okay, so these are the kind of questions that you see that scientists ask. Okay, in discovering day-to-day situation. Okay, so to score in experiment question, you must be proficient in several process skills such as hypothesis. You must be able to predict, right? Given data, given graphs, you must be able to predict what is going to happen after that in the next stage. Right? You must be very observant. Okay, you must observe the picture. Right? In PSLE, it's just graphics. Right? But if you are a scientist or you're working in the lab, you must be able to observe the experimental setup, every aspect of the experimental setup. So a scientist must be very observant, and you must be able to compare. Right? Compare. This is again a very important component. Many students, you must be able to identify what are the type of comparing question marks, because you do not use the right comparing terms, right? More, most, greater, better, those kind of comparative words. You must be able to infer, right? Given the data presented to you, given the graphs and given the table information given to you, you must be able to infer. You must be able to analyze and evaluate. Okay, so these are the kind of skills that you must have. It's not so straightforward. It's not so easy. That's why many students are not able to answer experiment type question, because the complexity of you must know many things, right? Many multiple process skills that you need to discover. Okay, and it can appear in both physical sciences as well as in the physical sciences as well as life sciences topics. Okay, let's take a look at some of the experiment type questions in the PSLE. Okay, so this is taken from the MCQ. All right, Davy conducted an experiment. Okay, on now experiment question is slightly different from application question, right? If you remember, the last week, right, we did a session on application question. Application question shows live day-to-day situation, and you're expected to apply the concepts to the concept that you have learned in PSLE science to the situation given to you. But an experiment question, okay, they give you an experimental setup, right? This is a typical experiment setup. typical experiment question where there is a setup. Like most likely it is taking place in the science laboratory. We have a lamp, you have a ruler for measurement. So there is a tracing paper, and you can see a water plant and inverted measuring cylinder and gas collected. And very important clue here, you have a graph, right? Graph shows the information, right? The scientist presenting the information collected from the experiment itself, right? Because when you conduct experiment, you need to present your answers, and one of the way to present your findings is through graphs. All right, sometimes through tables, through charts. Okay, so you can see here, Devi repeated her experiment. So we need to know why she repeat her experiment with increasing variable x and keeping all the other variables constant. Okay, later on we'll find out why you have to keep all the other variables constant. Okay. Now this is another type of another experiment question. You can see that a big clue here. They give you a graph, a table. A table shows the information collected from the experiment, and you can see this Ming Hao conducted an experiment using the setup shown below. So you can see a spring compressed, okay, and he measured the distance. So this Ming Hao measured the distance the block moved after releasing the spring. So you can see that this is under the topic of spring force or elastic potential energy. Okay, he repeated experiment in blocks made of the same material but various masses and area of contact with the table. Okay, so again, you can see this is an experiment question, right? Because there is a certain purpose of doing this experiment, and also the data collected is presented in the form of table. Okay, so this gives you a clue that this is the experiment question, and later I'll show you what are the steps or what is the thinking process when you see any experiment question, what should come to your mind. Okay, so to make it easy for you to analyze the problem. Next one. This is another example of experiment question under the topic of energy. Okay, Rita wanted to study the effect of some materials on the loudness of sound. Right, so you can see this is the aim of her experiment. She wanted to study the effect of some materials on the loudness of sound. She set up an experiment as shown below, and she covered the open side of a soundproof box with material P. So you can see there's material P. Right? And the clock was set to ring at certain loudness. She recorded the loudness of the clock, okay, with a sensor, sound sensor placed at. She repeated experiment using material Q and R of the same thickness. So you can see that she changed the type of material. So there is material P, material Q, and material R, while keeping the thickness of the material the same. Now, why does she keep the thickness the same? Okay, we will discover later. And this is what she measured. She measured the loudness of the sound using the sound sensor. Okay, so these are the various variables, and we have to understand what these variables are. Okay, and we have to understand the relationship between these variables. Right? Very good. Now, this is another example of experiment question under the topic of light. Okay, past PSLE question under the topic of light. Okay, so Zainal wanted to investigate which material was best at reflecting light. So you can see here, this is the aim of his experiment. She wanted to find out which material was best at reflecting light. So you can see he conducted with material P, material Q, material R, and material S. Okay, so he set up his experiment in the dark room as shown below. Zainal shined the light from the torch onto material P and walked towards it. Then he could clearly see, and when he could clearly see the material, he stopped and measured the distance x. So you can see here, this is what he measured. Okay, this is what measured. Later we're going to find out what you call this and what variables are this. Okay, they have specific name. All right, so the result of the experiment is collected and it is presented in this instance in the tabular form. Okay, so you must be able to analyze the table. You can see 290, 330, 300, 310. You must be able to make sense of the numbers here which is the biggest, which is the smallest, any particular trends, okay, you must be able to analyze, okay, and you must see and compare the difference between these two variables, the material, the type of material, as well as distance x. So all these things have specific names, and we will go through very, very shortly. Okay. All right. So far, everyone okay? I know. All right. I know. All okay so far? Am I going too fast or too slow? I'm sure most of you knows so far. I hope all of you understand what I've said so far. Okay, no problems, right? Okay, let's move on to the next part. Okay, so before we move on to answer some of the past PSLE question on experiments, we are going to review some of the key terms. Okay, I hope all of you would have understand or know most of these terms, right? Because okay, PSLE is very soon, right? These terms are nothing new. I'm sure your school teachers have repeated them many times, and in our tuition program also we have discussed many times, right? So this is nothing new. So this is just a recap session. All right. So first of all, when you see an experiment question, you must identify the aim of the experiment. Okay. So when scientists conduct an experiment, there must be a certain purpose, right? We will not conduct the experiment without any purpose. Okay. So the aim, usually it is clearly stated in the question, right? What is the purpose or what is the objective of doing this particular experiment? Okay. However, sometimes the aim of the experiment is not very clear, right? So they may expect you to infer the aim of the experiment from the information given to you in the question. All right. So what is the aim? The aim is a statement that describes the purpose of doing the experiment. Why the scientist, why the person in the question do the experiment? What is the purpose of the experiment? So when you are answering, when you are asked in booklet B, in the open-ended question, you are asked to identify the aim. So you can start the aim with to find out, to investigate. Okay, to find out. Okay, I want to find out how effective is this medicine, for example. I want to find out how effective is listening to music. How does listening to music affects our studies, for example? Right. So many kinds of experiment. Science is always about finding out, and scientists, if where they want to find out about certain things, they conduct experiment. Okay. Secondly, you need to know is hypothesis. Now, hypothesis is a prediction, right? A prediction of what is going to happen in the experiment. Okay, so after you state the or create the aim of the experiment, you must identify or you must predict, right? Before we conduct the experiment itself, right? We state the various hypotheses. We predict what could happen in the experiment. Okay, so probably a few statements, right? 2 or 3 statements, and then at the end of the experiment, we are going to show whether we are going to accept the hypothesis or we're going to reject the hypothesis. Okay, so creating hypothesis is part and parcel of doing a good experiment. Okay, thirdly is data, right? Data are facts and observation collected from an experiment for further analysis. Okay, there are many ways of collecting data. Now, let's say you want to find the speed, right? Speed of someone running or an object moving. You can use perhaps a stopwatch, right? Or you can use data logger can be used to measure many things, right? You can use to measure heat. You can use to measure the intensity of light, sound, heartbeat. Okay, so most of you have used data logger before. Okay, somebody asked, is it common for a question to ask about hypothesis? No, not really. Okay, hypothesis is not a very common question because it is very general. Okay, it's not a kind of a common question in the PSLE, right? However, they state in the question, and you're expected to know what is the hypothesis, right? So this is in the syllabus itself. Okay. Okay, so facts and observation collected from experiment for further analysis. right? So data can be many things, right? Light, heat, temperature, okay, height, right? That you have learned in your exam, in your syllabus, okay. Okay, next. Okay, these two are extremely important. If you are not very sure, please write down a piece of paper and you can ask me later on at the end of the session. Okay, these two variables are the most important part of experiment question. Number one, you must understand what is change variable. Number two, fixed variable. Change variable means the variables which are changed or manipulated by the scientists in the experiment. Okay, they are also known as test variable or the independent variable. Okay, and please take note that in any particular experiment, there can only be one change variable. Okay, there can only be one change variable. Otherwise, it will not be a fair test. Okay, so the concept of change variable is extremely important, and I mean, almost all the time they will have at least one or two questions asking you about the concept of a fair test. Okay, sometimes directly, sometimes indirectly, and even students who are taking foundation science also, the concept of fair test is extremely important. Okay, so I shall repeat: change variable, okay, are the also known as test variable or independent variable, and there can only be one change variable in an experiment. Otherwise, it will not be a fair test. You cannot have two change variables. You cannot be testing two things in the same experiment, but you can conduct it, of course, in another experiment, okay, to test other variables, another change variable. But in one particular experiment, you can only test one at a time. Okay, fixed variable. Now, fixed variable, there are other than the change variable, we call them fixed variable, right? You cannot in any particular experiment, there can only be one change variable. Every other variable must be fixed. Otherwise, it will not be a fair test. Okay, so variables which remain the same throughout the experiment, and we also call them as constant variable. Okay, we also call them as constant variable. Okay, somebody asked, is there a question where it is not given but you must find? Yes, of course. Okay, many questions, many times, the aim of the experiment is not given to you, is not clearly stated, but then they ask you in your open-ended question, what is the aim of the experiment? Now, what is the trick? Anyone can tell me, how do you identify the aim of the experiment if it is not clearly stated in the experiment? Anyone? Alia asked if what happened if they do not ask you the aim. I mean, they ask you the aim of to state the aim where the aim is not given in the question. Okay. Right. The answer is you have to look not at the fixed variable, but you have to look at the change variable. The change variable is the test variable, right? So from the change variable, when you identify the change variable, you can basically understand or determine what is the aim of the experiment, right? Remember, the change variable is also known as the test variable. This is what scientists wants to find out, right? So the clue to writing a correct aim of experiment is you need to have the change variable in your aim of experiment. Okay, if you do not have the change variable, your aim of experiment is wrong. Okay, so very important that the aim of experiment must have the change variable inside the aim of itself. Okay, yes, very good. Ifa, look for the change variable. Okay, Faris, now then you know. Okay, very good. At least it's not too late. Okay, right. Let's move on to the next part. Okay, result of the experiment. Now, what is result? When a scientist or when we conduct an experiment, we need to collect data, right? I want to test how fast the students can run, right? So the data collected is speed, right? Speed or the time taken for each student to run 100 meters, for example. Okay, if I want to find out the growth of the plant, right? I need to measure how high the height of the plant. Okay, if I want to find out the rate of photosynthesis, right? So probably I need to collect the amount of oxygen given out by the plant, measure the amount of oxygen. So all these things are called the result of the experiment. They are the data collected from the experiment, usually presented in table or graphical form. Okay, either table form or graph form. Okay, and result of the experiment is also known as the dependent variable. Why dependent? Because the dependent variable is dependent on the independent variable. Okay, now you don't really have to know, right? Some students are confused. Teacher, is it result or we call it dependent? Various schools call it differently, right? From my survey of various students in different schools, some of your teachers may refer to as the result of the experiment. Some of your teacher teach you dependent variable. So it doesn't matter. The main thing is you understand what you're writing and you understand the statement itself. Okay. So the result of the experiment. Okay. Next is the control setup. Now control setup is very important. Control setup uh, is a setup, okay, which is designed to minimize the effects of variables other than the change of the dependent variable. Okay, and remember, if they ask you about the control setup, you cannot just answer setup B is a control setup. You must elaborate why or how does it become a control setup, right? So a control setup, okay, is to basically you want to compare and confirm, right, that the result of the experiment is only due to the change variable. Okay, that the result of the experiment is only change variable. That's why you have a control setup, right? Please remember, you cannot just state the term it is a control setup. You need to elaborate how does it become a control setup. Okay. Fair test. Okay, we have mentioned just now, a fair test in experiment, in a science experiment, you have to ensure a fair test. How to ensure a fair test? By changing only one variable at a time while keeping all the other variables the same. Okay, all the other variables the same, we call them fixed variable. And the one variable that you keep, that you change, we call this the change variable, test variable. Okay, so conducting a fair test is very important. Okay, otherwise you cannot the result of the experiment does not mean anything. Okay, without example, let's say in the PSLE. Okay, PSLE, you need to ensure that everybody takes the same exam paper. Okay, everybody, the only change variable is the students, right? And the PSLE paper, it should be the same. Otherwise it's not a fair test, right? Imagine if the PSLE you have different schools having different sets of paper, right? It will not be a fair test for everybody, right? Okay, so remember in any particular test, experiment test, any experiments, it must be a fair test. How to ensure it's a fair test? We must ensure that there's only one change variable and other variables are kept the same, right? That's why you can see your PSLE, the papers are the same. Everybody start the exam at the same time, at the same time. Okay, and everybody is at different is at the same level, right? It's only at P6, not be at Sec 4 and then you sit for PSLE or your primary 2 sitting for PSLE. Okay, so the concept of fair test is extremely important in scientific research. Okay. Now, many students confuse, this take note of this. I see mistakes again and again. Student confusing fair test and variable test. Okay, a fair test, you ensure that there's only one change variable. But reliable test is very different, right? Reliable test means what? Okay, example, I'll give you a simple example. Now, let's say you come back home with a test result. Okay, and you show to your parent, oh mommy, I'm very sad today because I failed the test. Okay, I did badly for the test. Now, by showing one result alone, does it show your ability level? Is it fair to say that you are, you have not performed or you have not been studying for your exam, right? Just by one test itself, right, not determine, right, whether the achievement level of the student. Okay, so what you need to do, how to determine whether a student, right, is the achievement level of the student, whether they have mastered the concepts or not. How? By taking several tests, right? Taking many tests, right? You have the CA1 and the SA1, and your prelims test and so on. But of course, having said that, your PSLE, unfortunately, you only have one chance. Okay. But you have 6 years to prepare to study for your PSLE. Okay. So reliable tests, so how to ensure the results are reliable? You repeat the experiment. Okay, the exact experiment you repeat several times. Okay, now at your level, you can repeat 3 times. Okay, when you're conducting experiment in the lab, in classroom, you just conduct the experiment 3 times to ensure that the results are reliable. Okay, and when you repeat the experiment, okay, after 3 experiment, then you can take the average results, right? When you take the average result, use the average result. Okay, now of course in real life, to take only three times, to do 3 times may not be very good. Okay, I give you a very simple example. Now let's say a scientist in the pharmaceutical company wants to come up with a medicine that cure cancer, for example, right? The scientists would have conducted thousands and thousands and thousands of tests, right, before they actually sell the medicine or make the medicine available in the market. Okay, so you cannot just conduct three tests, okay, and then say that, oh, this is a very good medicine. No, right? Scientists, they conduct the test first at in the lab, and then test it on animals, on mice, on monkeys, on bigger animals, and then before selling, test on small human sample, right, for over several years, then finally releasing the product for the general masses. Okay, so that's why it's very important that you repeat the experiment to ensure that your results are reliable. Okay. Okay, I have a very interesting question for you. Now, let's say you have you conduct so you reach, okay, and one of the experiment, you know that the results are very it's not possible, not a possible result, right? Due perhaps to faulty equipment. Should you take the average of all the 3 readings? Should you? No, right? Okay, Navisa, why? Why you should not take the average of the 3 readings when you know one of the reading is a faulty result due to a faulty equipment? I give you a very simple example. Now let's take example of an exam, right? Your mid-year exam. So take English, Maths, Science, and Mother Tongue. Okay, and so one of the exam, let's say during the Mother Tongue exam, you were sick, right? You were sick, and is it fair for your teacher to give you 0 marks and then calculate the average of 0 marks for Mother Tongue and then calculate your overall result based on all 4 subjects? It will not be fair, right? Why? Because you are sick. Okay, so likewise, when you're doing experiment, you can simply say that, oh, I repeat the experiment and then take the average results. So you need to observe what cause, you need to see and the result of the experiment, analyze all the various data. Is it due to faulty equipment or is it due to something else, right? Okay, if it's just due to small variation, yes, you can take the average results. Okay, so I hope you get what I mean, right? Okay, so when you repeat the experiment to ensure the results are reliable, not necessarily that you take the average results only. Yeah, sometimes you need to discard some of the results and then redo the entire experiment and take a fresh new reading. Okay. Okay, Alia asked, does the question involve taking an average result? It depends, right? They may ask you in the MCQ question, right? I'm just getting you to think, right? Because some students, when I see write in the open-ended question, when I ask you, okay, how to make the results reliable, you say repeat the experiment and take the average reading. Okay, so it may not be 100% accurate, right? You may not just take the average reading. It could be other things also. So you need to analyze the situation. Okay. Usually they put in a graph, not necessarily. Sometimes it's just a table, right? Just a table will you can take the average already. Yes, depends on the you need to not depends on the scientist. You must depend on the data itself. Where is the source of of the error. Is it due to a faulty equipment? So let's say it's a faulty equipment. Do you think you should take the reading at all? Right? You should not. Right? You should discard and then repeat the whole thing again. Okay. So repeat the results for consistent and reliable results. Yes, correct. Okay, so that the results are reliable. Okay. Okay. We have not actually start into the answering technique. So now I'm going to go into the answering technique. All right. Okay. So all of you okay? Can Right. So if you have any further question, you just stick down on a piece of paper. I will address it later during the Q&A. Okay. Now 5-step thinking process. If you see any experiment question, whether MCQ or in the open-ended question, I would like you to think of this five process. Okay, when I teach my students, like during workshops or in our weekly classes, I give you in the form of table, right? So you have to write the answer point by point in the form of table, right? But in the exam, PSLE is not possible because you don't have the time. But this is the thinking process that when you see any experiment question, straight away in your mind, I want you to think of all of these 5 steps. Okay, I want you to think of these 5 steps. Number 1, you see an experiment question, first, identify the aim. Very important. Where is the aim? You look at the questions, right? Really identify, because sometimes students tell me that don't read the question, right? Because if the question is one whole page, right? You do not know where to start. Start from the top, start from the middle. Some students, they miss out important information. You just zoom into the pictures. All right. So here I'm teaching you the thinking process. You see any experiment question, step number 1, identify the aim. Right? Where is the aim of the experiment? Some very clearly, you underline the aim of the experiment, you highlight the keywords. Right? Sometimes it's not given in the experiment. Okay, so you need to identify the aim. Now, number two is identify the constant variable and the change variable. Very important, especially the change variable. Now, if the aim, you cannot identify the aim or it's not given clearly, next you identify the change variable, right? The change variable will give you a clue to the aim of the experiment. Okay, the change variable will give you a clue to the aim of the experiment, right? And sometimes, right, the question, the examiner wants to be cheeky, wants to be naughty. They purposely put more than one change variable, right? They purposely put more than one. Why? Then one of the question will be, they will ask you, is this a fair test, right? Is this a fair test? And then they ask you, why this is not a fair test? Or why do you think it's a fair test? Why do you think it's not a fair test? All right, so we have questions directly asking you about whether an experiment is fair or not, right? How to identify whether a fair test or not? Now, a fair test can only have one change variable. If there's more than one change variable, right, it will not be a fair test. Okay, so you need to make some modification, right? Sometimes in the question they ask you to modify or they ask you to change the setup. How would you change the setup? Make it a fair test, right? So you must refer back to the aim of the experiment. By looking at the aim of the experiment, you will know exactly what is the change variable and take note of the change variable. Okay? And step number 3, after you identify now constant variable, or step number 2, sorry, constant variable or the fixed variable, there can be many. Don't think there is only one. Change variable, yes, there can only be one, but constant variable or fixed variable, everything else must be fixed. Okay, everything else must be fixed. All right, so once you identify the constant variable and the change variable, step number 3 is to identify and analyze the results. Okay, identify and analyze the results. Now, what is analyze the result? Now, remember I told you that in an experiment, we collect, or the scientists collect data, right? And we have to present the data, right? If I'm a scientist, if only I know the data, right? Nobody will know unless I communicate my findings. So scientists communicate the findings in various ways. One of the common way is by presenting to you the data in the form of table. Sometimes they present it in a nicer way, present the data in the form of graphs, right? Pie graphs, line graph, bar graph. Okay, so step number, zoom into what is the result of the experiment, right? And not only you identify, you must be able to analyze. Now, what do I mean by analyze? Now, analyze, number one, right? Okay, I just show you one example. Okay, now let's take a look at this question. Okay, analyze, right? Now, this is example of the result of the experiment. Okay, now how do we analyze, right? Many students will ask, okay, what story can you tell about this table? Many students say that, hey, you take 2-3 minutes to think over it. Don't think so long. Straight away, you must be able to tell me, right? Which is the greatest, right? Which is the greatest result? So from here, straight away, you can tell that 330, right? Q gives 330, and which is the smallest? 290, right? So that is one of the most easiest observation by identifying the greatest amount, the greatest result, and the smallest result. Okay, and also results which are the same. Now, if the result, the data give you a constant reading, that means that it doesn't change. It also tells you something, right? Doesn't mean that only when you have an increasing amount or decreasing amount, it tells you something. If the amount doesn't change, it also tells you something, right? Example, let's say exam, you always get A star, A star, A star, A star. Does it mean that you're not good? Or does it mean that you cannot tell anything? No, I can tell something. If you're getting A's all the time, it means that you have been studying consistently, right? You have been studying consistently well, okay, and revising well. That's why you get A star, right? Doesn't mean that you need to show an increase or reduction of the result to give some form of conclusion. Okay, so you need to be able to analyze the result, identify the trends. What is the highest amount? What is the lowest amount? What is the average amount, right? So you must be able to analyze the data. And tomorrow I have a session on graphs. Okay, I will show you how to analyze graph. In graph, there are many types of graph. We have bar graph, we have line graph, we have upward sloping graph, downward sloping graph, right? You have U-shaped graph, V-shaped graph. Okay, you have plateau graph, erratic graph, many different types of graph. So you must be able to analyze those graphs. Okay, and from there you are expected to be able to answer the question related to the data given to you. Somebody asks, no, Nafisa, is it maths? Yes, science is maths, maths is science, right? A lot of science later on when you go higher levels, a lot of scientific concepts, physics, for example, lots of maths, lots and lots of maths. So that's why maths is extremely important. If you want to do well for all your subjects, you must master maths, right? You cannot escape. Okay, science, lots of maths, chemistry, physics, biology. Okay, yes, science is maths, maths is, all right, they are not independent, different topic. Okay, now step number 4, identify the science concept. Okay, after you identify step number 3, which is analyze the result, step number 4, you need to identify the key science concept. What is the concept they are trying to test you in the particular question? Right, remember in last week's application question, right? One of the steps to identify, to analyze application question is to identify the science concepts. So same, likewise, if you see any experiment, you must link to the topic and the concept. Okay, you must always link. If your answer does not have any concept, right? If you feel that it is a kind of motherhood statement or, no, right? It's likely that you most of the time you get 0 marks because this is not a comprehension question, right? Science exam, the examiner wants you to show understanding of the scientific concepts, okay? Your understanding of the question in scientific concepts. Please remember that you must always write, especially the questions with respect to the right concepts, and you must be able to elaborate effectively, okay, the scientific concepts involved. Okay, that's where you need to learn, you need to remember the concept, right? Every topic, for example, the topic of heat. What are the important concepts of the topic of heat? You need to know the concept of heat transfer, right? Heat transfer from a hotter region to a cooler region, right? The topic of water. Water, you have 5 processes, right? You have condensation, you have evaporation, you have boiling, melting, right? Boiling, melting, condensation, evaporation, boiling. Okay. And then under the topic of condensation, for example, concept of condensation, you must know what is condensation, right? Condensation is the change of state from gas to liquid state. Now, for a gas to change state to a liquid state, does it happen all the time? At which point does it condense, right? It will condense when the water vapor comes in contact with a cooler surface and there is a heat loss, right? When there's heat loss, then there will be condensation. So those are important concepts that you must remember the concept and must be able to concepts to the question, right? Let's say on the topic of energy, for example, right? You know about gravitational potential energy, right? You know about kinetic energy. So you must be able to explain the concept, right? What affects gravitational potential energy? Okay, as an object increases from the ground, the higher object is, the more gravitational potential energy, right? Or the mass, the greater the mass, the more the gravitational potential energy. So every topic, there are concepts. If you have not remembered, please do now. Right, I taught you many times to use a mind map. Right? Most of you who are getting A star, B's, I don't think you have problems remembering concepts. But those students who are getting 30 something, 40 something, 50 something, 60 something, some of your concepts you have not remembered effective enough. Okay, so please take this opportunity to remember to go through our notes and the booklets that I gave you. Right, write down. Please remember all the important concepts. Okay. All right. So after step number 4, once you identify the key science concepts, number 5 is you must be able to explain, right? Explain and link the concepts to the experiment itself. Okay, you cannot separate the concepts and the experiment. They are not two separate answers. Okay, you must be able to link, right? You must be able to. Later, I'll show you what I mean by this when we go through some questions. Okay, so explain the link between the key science concepts to the questions or to the context. Okay. All right. Now let's take a look at this question which I've shown you just now. I hope you can see. Okay, so this is an example of an experiment question. Zainal wanted to investigate, right, which material was best at reflecting light. He set up this experiment in a room as shown below. So remember, step number 1, identify the aim, right? Identify the aim. So you can see here, he wanted to investigate, right? So now this is the first line itself tells you the aim, give you an idea of what is the aim of the experiment. Okay. Then after that, you must be able to identify the constant variable and the change variable. So where is the change variable here? Anyone can tell me what is the change variable in this question? Type of material. Very good. Nafisa say distance. No, distance is not the change variable. Okay, distance x is what we call the result of the experiment. Okay, very good. The change variable, okay, is the type of material. So you can see here, material, right? The type. There are 4 types of material. Material P, Q, R, and S. Okay. Now let's take a look at the next one. Okay. So change variable, the type of material, the dependent variable, which is x, the distance between the torch and the wall. Okay, this is the dependent variable or the result of the experiment. Okay, and the fixed variable, everything else other than the type of material must be the same, right? Example, the amount of light given out by the torch, right? You cannot use different torch light for different experiment, for the same experiment. You cannot use one is with light with brighter intensity, the other torch with lesser intensity. So you will not be a fair test. And also the height of the material from the ground and the torch, the height of the material and torch from the ground must be the same, right? Okay, this part must be the same. Okay, this part also must be the same. Okay, so after you identify step number 2, step number 3, identify. Remember, I said identify, analyze the results. Now this is the result of the experiment. So from the table, you can see that x, or the distance, is greatest with material Q, right? Material Q gives you the greatest distance, and material P gives you the the smallest, the lowest distance. Okay, now step number 4. Once you identify the result, identify the key science concept. What concepts, what topic are they testing? All right, so you can see that this is under the topic of light. And let's recall, under the topic of light, one of the important concepts that you learn is that light travel in straight line, right? And another important concept is that light can be reflected, right? Light can be reflected. So here, they're testing you about the concept of light can be reflected. And they also tell you that from this experiment, you can tell that light does not reflect the same way for all materials, right? You can see in some material, the light reflects more than the other materials. So some materials are a greater reflector of light compared to other materials. Example, when you are cycling, right? When you are cycling at night, we would want to wear clothing which are lighter, right? Why? Because lighter colors are a better reflector of light. Likewise, your bicycles, you have reflectors. Why? Because to keep you safe, so that people from far, right, can see your bicycle better, right, compared to something which is a poor reflector of light. Okay, so step number 5. After you identify the concepts, you must be able to explain. Okay, you must be able to explain, link the table here to the concept. So you can see that Q is the greatest reflector of light, right? Why? As it is able to reflect light to the furthest distance. Okay, it is able to reflect light to the furthest distance. Okay, so all 5 questions should come to your mind. Okay, you are not supposed to write the table like this, please. Okay, we don't have time, but these 5 steps must come to your mind, your thinking process. What I'm teaching you here is your thinking process. If you see any experiment question, identify these 5 steps. These 5 steps should be in your mind, and you must quickly be able to answer, because you know, in the science, time is very important, right? You only have 1 hour 45 minutes, right, to answer both booklet MCQ as well as the open-ended question, right? And we can see some of you say that you don't have time, right? Why you don't have time? Because you are not quick enough, right? Remember the PSLE, you don't have the luxury of time to take home, to do as homework and so on. So time is very, very important. Okay, so if you you should actually do some conditioning at home, right? Where you sit down and take, practice actual exam paper, the full paper under time condition before your PSLE itself, so that to tune you to prepare for the to manage the time better. All right. Okay, now let's take a look at the next question. Another example. I just give you a few examples. Okay, it's almost 5 more minutes to 9. Okay, don't worry. I will go a little bit quickly. So this is another example about energy, sound energy. Okay, Rita wanted to study the effect of some materials on the loudness of the sound. So you can see that again, the type of the aim of the experiment is given to you. Okay, the aim of the experiment to find out if the type of materials affect the loudness of the sound. So you can see here in the aim of the experiment, this is the change variable. The aim of experiment must have the change variable. Please take note. Some of you, some of the students, I ask you to write the aim of the experiment, you don't have any change variable. Okay, please remember, this is very, very crucial. In your aim of experiment, you must have the aim, you must have the change variable or the test variable. What are you trying to test in the experiment? What are you trying to find out? It must be clearly stated in the aim of the experiment. Okay, so step number 2, you identify the change variable and the fixed variable. Now, change variable, you can see this is a type of material. Type of material is the change variable. And the dependent variable, which is the result of the experiment, is the loudness of the sound detected by the sound sensor. So in this particular question, they use a data logger, the sound sensor, to measure sound, right? Sound is not easy. Using your ears itself, it may not be easy to differentiate different types of sound. Okay, so sound sensor, you'll be able to measure more accurately. Okay, and then from here, the change variable is the fixed variable is the distance between the sound sensor and the box, right? So it must be the fixed distance. Okay, it must be fixed. If not, it will not be reflected, right? Okay, the loudness of the sound given out by the clock. Okay, the clock also, it must be, because you are not testing the different type of clock. Remember, you are testing the different types of material, right? So the sound which is given out by the clock, okay, must be consistent, okay, for all the different materials. And the thickness of the material, okay, the thickness must also be the same. Now, please take note. Here we are measuring the type. The type and thickness is different, right? Type of material could be, one material is made of metal, the other one probably made of wood, the other one made of cloth, right? Thickness is 1 centimeter, or you want it to be half a centimeter or so. So the type of material and the thickness of material, they are different concepts. Okay, step number 3. Once you identify the two variables, next is to identify the results. So you can see this is the result of the experiment given in the table. So you can see material P allows most light to pass through, right? This sound sensor detected most amount of light when you use material P, and the least amount of, sorry, not light, sound, least amount of sound when you use material Q. Okay, so this be able to analyze the result of the experiment. Okay, step number 4. Once you identify the result of the experiment, you need to identify the key science concepts, right? So science concept here, you know that sound energy travels and can pass through different materials. This is a past PSLE question. So explain the link between the concept to the question. Material Q is best at reducing the amount of sound energy passing through it. Why? Because we can see that the amount of light, amount of sound detected is the least when you use material Q. Okay, so you can conclude that material Q is best at reducing the amount of sound energy passing through it. So let's say you have a bedroom and you want to install curtains, right? So you do not want to be disturbed by, say, the vehicles outside the house. So you may want to use the material of the curtains, which is made of material Q instead of made of material P, right? Okay, next question. Oh, we have 2 more questions. We have 2 more questions. Are you okay? Can? Okay, let's go through one last question. Is it okay for all of you? Okay, we are at 9 o'clock. I will need to give you some time for Q&A. So I'll go through a little bit quickly. Okay, now let's take a look at this question. Again, this is this is another type of experiment question. So John had 3 tubes S, T, and U containing equal amount of chloroplast mixed in the same amount of blue liquid. So this is on the topic of photosynthesis. Okay, on the topic of photosynthesis. So how do you know? You can see the word chloroplast, right? Chloroplast on the leaves. It is used to trap sunlight, right? So he switched on the lamp, right? When you have a lamp and you have and recorded the time taken for the mixture to turn green, he experiment with tube S and U at the same various distance from the lamp as shown below. Okay, so you can see here, tube S, the distance is 10 centimeter. The time taken for the mixture to turn green is 9, and for T is 22, and for U is 30. Okay, so what is the aim of the experiment? To investigate how the intensity of light, how the intensity of light affects the rate of photosynthesis. Okay, so how do they differentiate or change the intensity of light? By moving the distance, right? By moving the distance of the setup from the lamp. The closer the setup or this mixture from the lamp, the greater the the intensity of light. Okay, so the aim of the experiment, the constant variable and so the change variable is the lamp, the distance between the lamp and the mixture, and the dependent variable is the time taken for the mixture to turn green. Okay, that is the dependent variable. Right, you can see here, this is the time taken for the mixture to turn green. And next, step number 3 is identify and analyze the results. So from the table, you can see that as the distance between the lamp and the mixture, right, the time taken for the mixture to turn green also increases, right? So that means basically it takes a longer time for photosynthesis to take place. Why? Because you can see the intensity of light has decreased. Because why? It is further and further away from the lab. Right. So what is the science concept here on the topic of photosynthesis? Let's recap. What is photosynthesis? We know that light energy is needed for photosynthesis, and you also need carbon dioxide, right? You need water for photosynthesis. But in this particular question, the component that they are testing you is that is light. Okay, and you can also tell that the greater the intensity of light, the faster or the greater the rate of photosynthesis. So this is what they can conclude from this experiment. And step number 5, you must be able to link the concepts to the particular question itself. So the higher the intensity of light, okay, the faster the chloroplasts carry out photosynthesis. All right, so this is how you should be able to explain. Okay. All right. One last question. Last question. So this is on the this is topic of heat. Topic of heat. Haziq used the setup shown below to find out how the type of bulb affects the temperature of the surrounding. Okay, so you can see here, this is the aim of the experiment, right? Straight away, without even looking at the setup, I can tell what is the variable. What is the change variable? Type of bulb. Okay, now in the market, there are different type of bulb, right? Some bulbs produce heat, some bulbs produce lesser heat. Okay, and so bulb R was lit up. He covered the box and recorded the temperature of the air in the box over a period of 10 minutes. He then removed bulb R and left the box uncovered for 50 minutes. Why? Why must leave the box uncovered for 50 minutes before you repeat the experiment using another bulb? So this they will ask you in the question. And this is the result of the experiment, the different types of bulbs. And you can see that at the start of the experiment, the temperature of the air in the box, right? The temperature of air in the box is the same, right? And what variable is this? This is what we call the fixed variable. Remember, the constant variable. Okay, this must be the same. Otherwise, it will not be a fair test, right? Remember, the change variable is the type of bulb. There can only be one change variable in the experiment, which is the type of the bulb. After 10 minutes, what is the temperature which is measured by the data logger? Okay, now let's take a look at the answer. So fill in the box. So you can see here, now in this particular question, I didn't show you the table, right? Why? Because you don't have to draw the table or write the table in the exam, right? It's impossible. But I want you to use the same thinking process as what I've shared with you, right? This is a secret recipe, I would say, right? Step number 1, step number 2, step number 3, step number 4, step number 5, right? This thinking process must be in your mind, right? This is the heuristic thinking of analyzing a question. Okay, so once you are able to analyze, then you can answer the question very easily, right? Fill in the boxes to show the energy changes in the box, and then give a reason why Haziq left the box uncovered for 50 minutes before. Okay, and then which bulb, R, S, or T, should Haziq use to light up his room so as to reduce the energy used by the air conditioner? Okay, so with this, with the understanding of the 5 steps, you will be able to answer any kind of question related, okay, to the setup